All right, welcome to today's math lesson. We are talking about the difference between perimeter and area. You are going to need a scarlet color, or like a bright bold orange, and an apricot or peach color. You need your journal to look like this. Don't forget to put the date in the box and also to get all of these definitions written. Go ahead and push pause on the video until your journal looks like this. Okay, so let's quickly read through what the definition is of perimeter. To find the perimeter of a shape, what you do, or what it is all sides of a shape added together. It's the distance around the outside of a shape. Okay? Some examples of perimeter would be maybe building a fence. And you've just watched that introduction video that was kind of a fun rap song. And it was about colonizing Mars and putting, fences and gardens and building things on Mars. So one example of a time when you would use perimeter is if you were going to build a fence. Okay, a fence typically goes around the outside of someone's property or a small area. So a fence. You might also use perimeter if you're talking about a border. Maybe the perimeter of the outside of some type of field. So the outside of a field or court. You would use perimeter if you're talking about how far around something is. Another example of this might be a lap around a track or something like that. Those are all examples of times when you would use a perimeter. Wallpaper, sometimes if you have like a border of a wallpaper, or frames. A frame is a good outside of a frame, like a picture frame. All right, those are all good examples of perimeter. What are some good examples of finding the area in the real world? So here's what the definition of area is. The total surface of a 2D shape being covered. Okay, it's the total surface being covered, and each part inside of that surface is broken up into square units. Okay, so if we're talking about inches, then it's square inches. If we're talking about meters, then it would be square meters. But you kind of saw in that video that they break up the interior space into square units. Okay, that's why when you find the area of something, the answer has to be in square units. It has to be inches squared or square inches. You have to label that correctly. So here are some real life examples of when you would need to find the area. Maybe you are planting new grass or spreading soil or laying sod. So I would say sod, grass, soil. Those are all examples of when you would find the area. Maybe you are painting a wall. You have to cover that whole surface of the wall, right? So painting a wall would be a good one. Tiling the floor or laying down wooden floors or carpet. So I would say floors/carpet. Or tile. Oh, what about this one? How about wrapping a present? You have to cover the surface of it, right? You don't just go around the top border or around the edges. You cover the whole surface. So wrapping paper. We'll say wrapping a gift. I think anytime you're talking about gardening or planting something in the soil, we kind of already said soil, that would work for that. We got the painting a wall, laying carpet. When else would we maybe need to find the area of something? Oh, we might need to find the area to know, like if you're spraying down a pan, like for baking. Baking sometimes needs the area of the inside of a pan. Okay? Those are all examples of times when we maybe need to find the area. So there is a formula that you use to find the area of a shape, and the formula for area is just all sides added together. So you just kind of go like this. The perimeter formula equals the sum of all sides. That is how you find the perimeter of a shape. You do the sum of all sides. And you need to know that in a rectangle, opposite sides are equal. So if the right-hand side of this rectangle we just drew was 3, then what would the left-hand side be? It would also be 3. If the bottom was 12, what would the top of the rectangle be? It would also be 12. Okay, so you need to know the opposite sides of rectangles are equal. So to find the perimeter, you just do the sum of all sides, and you know that sum means to add. And then to find the area of something, whoops, I just wanted to put the equal sign and I put it as part of the letter A. That was so funny. If you want to find the area of a shape, you have to do something a little bit different. What do you do to find the area of a shape? You take the length and you split that into units. You split the length into units. Then you multiply that by the width split into units. And that will give you the square units inside of the shape, or the surface of a shape. Okay, I'm actually going to add the word surface to our list of examples. That's going to help you know to use area. So again, area is taking the length times the width. Ooh, how fun, I just broke my crayon. It's going to be fun for the rest of this lesson. Okay, so we have perimeter and we have area. We're going to be doing a lot of examples and a lot of practice problems with this, but really it's about looking at a problem and knowing how to find both the perimeter and the area, or it's to look at it and go, what are they asking for here? Are they asking for perimeter or are they asking for area? Okay, that's going to be what's so interesting. So you need to find page 323 in your math workbook. Go ahead and pull it out and rip it out, and let's get practicing with area. We're going to be practicing all of page 323, finding the area, but you also need to know how to do the perimeter on this page. So you're going to want your name and number at the top. Again, it's page 323. Push pause on the video until you get yours ripped out and your name and number at the top. Okay, it says practice with area. Find the perimeter and the area of the rectangle. When possible, express your answer as a whole or mixed number. So perimeter, remember, is to add all sides. So the perimeter would be 1/2 plus 1/2. So the 1/2 plus the 1/2. Watch how I'm going to do this. Where's another line that looks like the 1/2 that's going parallel to this line, meaning it's going up and down just like this one? Oh, it's the height of the shape or the width of the shape. So those would both be 1/2. So that's kind of where I'm going to say I have this 1/2 and I have this 1/2. And now let's use that other color of ours, whether yours is broken or not, like mine. I've got that 1/2 at the top, and I have this bottom 1/2 as well. So I have 1/2 plus 1/2 plus 1/2 plus 1/2. You need to be able to quickly add those in your head. 1/2 plus 1/2 is 1, and this other one is 1, so the total is 2 centimeters. If I were to build a fence around this square, I would need 2 centimeters to build it. Okay? And how do we find the area? Area is length times width. So I'm going to do 1/2 times 1/2. When you multiply fractions, remember you just multiply straight across. You could look for relationships first by extending the bar. but there are no relationships, so you just do 1 times 1 is 1, 2 times 2 is 4, but then what is the unit measurement? Remember, I was doing square units, so it has to be centimeters squared, or you can say square centimeters. I'm going to circle that one, and I'm going to circle my answer for perimeter as well. Okay, number 8. To find the perimeter of this, we have, doesn't matter which color you do, but I have a 2 meters, and where's the other one? Where's the other 2? Oh, it's directly across from it because opposite sides of rectangles are equal. So here's the other one. So I have another 2. Then I have 10 4/5 across the top. And then I have 10 4/5 across the bottom. So I'm adding all of those sides together. 2 plus 2 plus 10 4/5 plus 10 4/5. I would do some of the associative property or start grouping things together how you want to because they're all addition. So I'm just going to show this. 2 plus 2 is 4. 10 plus 10 is 20. And 4/5 and 4/5 is 8/5. So I have 4 plus 20 plus 8/5 equals 24 and 8/5. But you can't leave it as 8/5. You know you have to fix that. So we fix it. 5 goes into 8 one time. There would be 3 left over, 3/5. So I have the 24, and now I have, this is that Medal of Honor, 24 and 1 make 25, and I have the 3/5. And then it would be meters. So yeah, perimeter is easy, but now that you're in 5th grade, we're going to be making this a little more complicated by giving you fractions and decimals and making sure you know how to do that. Okay, so the answer for perimeter on number 8 is 25 3/5 meters. All right, let's move on to area. Area is the same as it always is. You're going to be doing length times width. So you can put 10 4/5 because that's the length times 2. How do you solve a problem like this? You are going to multiply, then add, change this into a fraction. 5 times 10 is 50, plus 4 is 54 over 5. How did you know it was over 5? Because the denominator is stubborn and it stays. So I have 54/5 times 2. What do I do with that 2? I put a 1 underneath it. And I extend the bar. Do you see any relationships between these numbers? There's not. So you are just going to multiply straight across. 5 times 1 along the bottom is 5. 54 times 2? Well, I know that 50 times 2 is 100, and then 4 times 2 is 8. So it's 108/5. You definitely don't get to leave it as 108/5. So you do 108. What does this line mean? What does that fraction line mean? It means divided by. So you do 108 divided by 5. 5 goes into 1. Nope. 5 goes into 10 twice. Bring down the 8. 5 goes into 8 once. And I have 3 left over. I could do a decimal and a drop down 0, but they're working with fractions, so why don't I take the remainder and make it into a fraction? A 3 is on top, and what's the denominator? It's 5. So it's 21 3/5 here actually. And it's meters squared, or square meters. I'm just going to do an m with the baby 2, an exponent 2. That is crazy that it takes that much work to solve that problem. So yeah, you know, the lesson for learning how to do perimeter and area is an easy lesson, but putting it to work with these numbers is what's going to take you time today. So be prepared for that. I think the next one's going to be pretty easy. Perimeter, add all sides. 5 plus, you have to go opposite of it. We're going to use these colors again. Doesn't matter what color, but do the same line. So 5 plus 5 and 4 plus 4. Much easier than dealing with fractions. Well, 5 plus 5 is 10. 4 plus 4 is 8. So it's 18 inches. As we start doing measurement like this, you must put the label. If you do not put the label on an answer like this, you will get it wrong. Okay, to find the area, we do length times width. Well, this one happens to be 4 inches long and 5 inches tall or wide. So it's 20. And you can do inches squared, or you can write it like this, square inches. Doesn't matter. Let's look at number 9 and really break this one up. I think this one's really cool to be able to do that. So what it's saying is, going from left to right, we need 4 units. 4 units going this way. So we go like this. Okay. Do I have, if I draw these lines like that, 4 units going across? 1, 2, 3, 4. Yep. Now going the other way, I need 5 units. One, 2, 3, 4, 5. So I know my boxes aren't perfect, or they're not square exactly, but you get the idea of, if I were to count up every single one of those little unit boxes, because I have 4 going left and right, 5 going up and down, I would get 20 little squares in there. That's why it's 20 square inches. Pretty cool. All right, number 10 is definitely going to be harder, and you can tell because there are fractions. Okay, perimeter. We're going to do 2/3 plus 2/3. Whatever you have on the left, you have on the right. So actually, I'm going to do all the work. Actually, no, I'll put it right here. That's fine. 2/3 plus 2/3 plus 1 4/5 plus 1 4/5. I know that these two together, 2/3 and 2/3, make 4/3. I'm just going to stack it up. 4/3. I know that 1 and 1 make 2, and 4/5 and 4/5 make 8/5. So look at what my addition problem has just become. 4/3 plus 2 and 8/5. I know they're improper. It's okay. Use those improper fractions to add and then fix it all at the end. So I cannot add these fractions together yet because they have thirds and fifths. They have to have the same denominator. What can thirds and fifths both be changed into? This is clear back from the beginning of the year. You have to think, what can a 5 change into that a 3 could also change into? It's 15. You're going to change both of those to be 15ths. So you ask, how did I get from 5 to 15? I times by 3. And 8 times 3 is 24. How did I get from 3 to 15? I times by 5. And 4 times 5 is 20. Wiki wiki, right, on all of that. So I have 20 15ths plus 24 15ths is 44 15ths. And then I still have that whole number, 2. But this has to be fixed. You can't leave it as 44 15ths, so you have to ask. You're making a Medal of Honor, don't forget that too. How many times will 15 go into 44? Oh, it almost goes in 3 times. Because 15 times 3 is 45. But it only goes in twice. And so you take away 30 from there, and you get 14/15. So I had the 2 from before, and now I have this 2 and 14/15. So my total is 4 and 14/15. What's the measurement? Centimeters. That's crazy. That is the perimeter. Okay, the area, length times width. The length is 1 4/5 times 2/3. Well, you can't multiply a fraction with you can't multiply the mixed number until you go multiply then add. Change it back into a fraction. Multiply then add. 5 times 1 is 5 plus 4 is 9 over 5. How did you know it was over 5? Because the denominator is stubborn and it stays. Okay, and then you keep the 2/3. You do not flip anything. We're not dividing. You only flip when we divide. And we're multiplying. Plus, I see a relationship. You see it? The 9 and 3. They can both be divided by 3. Makes that one be 1. And 9 divided by 3 is 3. So no other relationships are there. So now I multiply straight across. 3 times 2 is 6. 5 times 1 is 5. And 6 over 5 equals 1 1/5. But it has to have a label. And it would be centimeters squared. Or square centimeters. That is the area. So I'm just going to kind of show this. This is the area. And this is the perimeter for that problem. Pretty crazy, right? So the lesson seems easy, but putting it to work is a little more difficult. I think practicing those kinds of things are really, really important. And I do want to try a couple more with you. So I would like to try number 11. Okay? If they give us the area of this rectangle, and they give us the width, or the height, whatever you want to call this, then how do I find that missing piece, the length? Think about it. Normally I've been doing length times width equals area. But now I've given you the area and one piece. So how do you reverse multiplication? Division. You're going to be using division, okay, when you're trying to find a missing piece of that. So you take the area divided by the width, and it should give you the length. So go ahead and stack this in a long division problem. 29.76. I'm just going to write it right here. Divided by 4.8. Well, this is the division with decimals. You cannot do this if there's a decimal in the divisor, so you have to move it. You times it by a 10 to the first power so that you get a 48 instead of 4.8. And instead of this being 29.76, you also, if you might multiply this by 1, you also have to multiply that one by 1. Or, sorry, by 10 to the 1 power. So it becomes 297.6. And now I need to move that decimal straight up into my quotient. Lots of decimal steps here. Okay, all of that to be able to begin the division. You ready? 48 is close to 50, which is going to be nice. 50 or 48 won't go into 2 or 29, but they will go into 297. And 297 is close to 300, right? So 50, 100, 150, 200, 250, 300 would be 6 times. And that's a little too high, but I was counting by 50s and the number is really 48, so I think we should try 6. Let's come over here by number 11 and try 48 times 6. It's 288. So it worked. Could I get 40 more before it blew the roof? No. So 6 goes. Where does the 6 go? It didn't go into 2. It didn't go into 29. So the 6 should go above the 7 because it went into 297. All right. And then I subtract. And I bring down. How many times will 48 go into 96? I start over. And it's exactly 2 times. You're welcome. I'll just tell you that. 48 times 2 is 96. So, what is the side length of this rectangle? It's 6.2 meters. Why is it not meters squared? Or square meters? Because it wasn't the area. I was taking the square meters and dividing it by one of the meters, so then I got only a meter left. That's how that works. Pretty cool. Meter times meters is square meters. But if you go square meters divided by meters, then you're going to get just a meter because it helped build it up. Does that make sense? Okay. Let's skip a roo, and go to number 14. Number 14. Okay, they gave me the area, 7, and one of the sides. So what do I use to get to the other side? I use division. If they gave me the width or the height and the length, then I would not use division. I would use multiplication. Okay, so I use division. I take the area, 7, and I divide it by the piece or the side, which was 1/2. Woo! We finally have a division problem with a fraction. To divide by a fraction, here's a tip. Keep, change, flip. So you keep the 7, you change divide to multiply, and this time you flip it because we were dividing. So how do you flip 1/2? You flip it to, instead of 1 over 2, it becomes 2 over 1, but I never write it if it's over 1 because, I mean, you could, but it just becomes 14 over 1, which really is just 14. The answer is 14. This one's always really interesting because kids have a hard time thinking, wait, how can one of the lengths be greater than the actual area? It's because they're different types of measurement. Remember, the ones on the outside are just measuring a line. How long is that line? The number on the inside is measuring how many square yards are in here, square units. So the line might be longer, but it's not two-dimensional. It's just one dimension, one measurement. So that is how the number seems larger, but it's really not. It's based on what we're looking for. Super interesting. In the next video, we're going to take a look at page 324. So we'll see you then.